We are live. Hi guys, hi. Darren and Phil, can you see my screen okay?
Yep. All
Perfect.
good.
Hi guys, so you've got Daisy here from HackerJob and we've got Darren and Phil here today as well. I think we'll just wait a couple of minutes just to make sure that everyone's joined and then we'll get started. How are you guys?
Good. Yeah, fine. Darren?
I love the first 20 seconds of these because I always see the same 8 or 9 names that are always the first ones that come in.
Yeah, we should have some sort of fastest finger first bonus.
Rewarding prize.
Getting in nice and early, yeah. But no, all good. Excited to go through the wonderful world of automation, nice and varied. I think we touch on 3 or 4 of the topics that we've kind of already touched on. I hope it'll bring some of that together. So yeah, should be an interesting one.
Yeah, definitely. I'm excited to learn about automation engineering. So yeah.
Lovely.
Darren, has any footballers been playing at the moment? What's the match of the moment?
So I'm an Arsenal fan, so I don't really want to talk about football at the moment.
Oh, okay.
So we did get to the FA Cup final.
You've just got the FA Cup final. Arteta finally looks like he's getting the team playing the way. But
yeah.
Look, stop me there. You're an Arsenal fan. You're never going to be happy.
Well, all my family are Chelsea fans, so all I hear from my dad whenever I ring my dad is how good their team is going to be next season. And I'm looking at the fact that Arsenal have got about £6 and a penny to our name. So, despite being owned by the man who owns Walmart, so he's not really lacking money, but that is the life that I chose, unfortunately. And you're a Newcastle fan, so I guess I can't moan too much.
Yeah, exactly. I sat through the most boring match in history yesterday, on Newcastle-Brighton. Second time that's happened this season. Ever get a ticket for a Newcastle-Brighton game? Give it away.
I don't think I'll go to that. Daisy, what's going on in your life?
Well, not football. What have I been watching? Do you know what? So I saw this program on Netflix called Indian Matchmaker, and I started watching that last night, and it's great.
Is that like Love Island, but Indian?
Well, it's like it's like a more mature version of Love Island. It's like reality TV, and basically it's people who want to find love. They're of Indian heritage, and they meet with this matchmaker who is apparently the best matchmaker in the world, and she gets flown all over the world to match people. So
nice.
Yeah.
Nice. Any good matches so far? Are you expecting many marriages?
I don't know. So I should say as well, with the arranged marriage concept here, these are adults who want to be in an arranged marriage. Their parents aren't so involved in it. It's them. They've got careers, and they feel like they're of a certain age, and they want someone to just basically do all the hard work for them. But yeah, there's a couple of people. There's a couple of people who seem interested, who seem like they're going to have good dates and stuff. So yeah.
Cool. Lovely. 10 minutes past. I don't know if we want to get started.
Yeah, sure. Let's get started. So, so we have a Slack group that is now live. We are trying to add people to it as quickly as possible. Slack gives us a daily and a weekly limit of how many people we can add to the group, but we are trying to add people as quickly as we can. Also, when you're asking questions in Zoom today, please add to all participants if you don't want your questions to be private, and that just means that everybody who's live with us can kind of see the questions. And you'll be invited to a new Zoom webinar each week, and just email hello@hackerjob.co if you have any issues. And yeah, just make sure to tell your friends. So obviously we are live on YouTube, and we now have a dedicated place on our website for all the kind of YouTube videos and all the slides and stuff as well. You can follow us on Twitter at hackerjob.co and LinkedIn by hackerjob as well. And if you want to share anything about these sessions, please use the hashtags TRT and Tech Recruitment Training. Right. So obviously we are only a couple of weeks left of this kind of cohort before our kind of summer break. So today we're covering automation engineers, and then next week it will be AI engineers. So Phil's going to take us through the session today, and Darren will be on hand to kind of facilitate the Q&A. And I'm just here to kind of host the session. So yeah, Phil, do you want to take us through today's agenda?
Yeah, absolutely. So I think a good place to start is kind of what draws these roles that we're going to look at together. So we'll have a look at what automation is. Why would you kind of automate? I think some of it will be quite obvious. Other bits, hopefully quite interesting. We'll look at kind of the history of automation, various different types of automation engineer, because it does, it isn't one discipline. It is more of a cultural thing in the same way that DevOps is. And as we go through, we'll see that there are a lot of correlations between kind of that world of DevOps, the world of kind of real-time streaming that we've touched on, and why that's had a big impact on how much businesses can automate. And then we'll have a look at some of the tech within those roles, skills within those roles, and then a bit of a look at kind of the experience and salary levels we're looking at for them as well.
Awesome. So what is automation, Phil? Tell us all about it.
Yeah. So I thought this was quite a nice explanation of it. So automation software is the use of instructions to create a repeated process that replaces an IT professional's manual work in data centers, cloud deployments. It's basically software tools or frameworks and appliances that help you conduct tasks with minimum administrator intervention. So when we're talking about making businesses scalable, making tasks repeatable, then automating your workflow leads to lots of different benefits, including quality, speed, and things like that we'll come on to throughout the presentation.
Nice. And I take it, so this is obviously looking at the history of automation.
Yeah, absolutely. So I think, automation essentially started with programming. If you think of what programs are, they're automating simple human tasks, even if it's, I don't know, the difference between having a manual calendar that you have to kind of add to on your wall and having a calendar on your computer at a very basic level. That's automated your process of managing your schedule, allows other people to interact with it and add meetings in there and things like that. So at a very basic level, automation started, well, as soon as technology started advancing into the IT world. I think we did some really good kind of history of development sessions in series 1. So if you do want to look back a little bit more at kind of like where that data world came from, and where a lot of the kind of software development principles came from, then we're looking right back into the, as far as the 60s. However, really, it was the 1980s where we really started to see, obviously, the big kind of commercialization of computers, businesses around the world kind of bringing them into the business and then using them to start automating their various flows. So I think some kind of points to look at would be sort of the rise of UI automation, which is around the 2000s. If we look there, there's a focus on UI automation only. So what that is that's kind of reading user interaction on their actual desktop. So it's allowing the computer to send reports back to the development team about how users are interacting with their software. But it's quite basic. It's based only on the UI. So it's based only on, are they clicking here? Are they using this feature? So it's quite a kind of surface level analysis. But that, I think, was one big step, because then we started to automate a lot of the reports and start to gain a lot of data on how users were interacting with the software. We then, I think, obviously you can see that there are lots of developments there. Selenium comes out in 2004, which is, to be honest, still the most widely used tool on the market. Obviously it's gone through lots of different iterations there. WebDriver, you can see there in 2008. But I think the next thing we want to look at is the automation pyramid, and we'll come on to that in a little bit more detail in a second. But essentially that was an ideology or a culture that businesses started adopting, which was trying to automate at all different levels of their business, from kind of factory floor automation. So that might be, the automation of very simple tasks, right the way up to the kind of top C-level automation, which is your automated data reports, so that your business can utilize that information to make decisions. So that's a methodology, I suppose, that came around just after 2010. And then what we're going to move to is where we are now with automation, which is kind of mobile and continuous testing. So within that, it's constantly feeding back information to the business on how they might want to kind of change the business model, or they might want to release a new product to fix a certain issue. And it also allows us to automate lots of small repeatable tasks as well. So I think in the last 5 years, with the rise of kind of the massive expansion of the cloud platforms and the massive computing speed that gives us, it's really driven the world of automation within tech on. Cool. So this is a quick graphic on the difference between UI automation and API automation. So as I mentioned, UI automation it came around in the early 2000s, and it's basically analyzing what someone is doing on their desktop screen. API automation, that's automated reporting based on how people are using APIs. So how are they using a certain app on their phone? How are they so it's obviously collecting a lot more data. If you're looking at the data on how someone is using Netflix, or how someone is using WhatsApp, or how someone is using all of these different apps that, yes, you have given them permission to use your data on. When we all sign that disclaimer at the start of signing up on any app, they are analysing the majority of the data that goes through it. So obviously it adds a lot more richness, a lot more complexity to the data that they can analyze. So they're both going into the same flow, but the reports that are generated are a lot more detailed and a lot more nuanced when you're looking at API automation rather than UI automated reporting. Cool. And then the automation pyramid here, as I said, this was something that came around about sort of 15 years ago or so. And again, it's more of a methodology. So if we look at the top level there, you've got enterprise level with kind of ERP systems, so reporting and providing that information to the top level, the top level of the C-level, sorry, so that they can make decisions. You've then got manufacturing execution systems, plant-wide operations, handling of data gathered from multiple sources. So that's, you know, your top level infrastructure. You've then got the supervisory level. So this is about kind of input and output data management, mathematical models, recipe management, learning, reporting. So it's allowing managers to manage better, essentially. It's giving them the data on their teams and how they're working. You've then got operational level, and then you've got the field level. So things like sensors, actuators, hardware, things that are on the ground level. So while this has, you know, main implications for the manufacturing world, I think you can, you know, everyone can see how I don't know, the Ford factory or the VW factory would utilize automation right from the bottom, which is kind of robotic automation and sensors and things like that, all the way up to the top, which is data management. But it's also something that we've seen span IT businesses as well. So whether that is on a field level, building tools and you know, automating processes so that your day-to-day software developers or your testers or whoever it is, so that their job is easier, as well as bringing in reporting software and management software and HR software so that your management can analyze the work that the teams are doing and be fed that information. Or it's reporting software at the very top. So you're looking at the financials and you're looking at all of the various data points that are going to be relevant to making big decisions for the business. It's still a methodology that applies to IT businesses as well.
So talk to us about automation engineers.
Absolutely. Cool. So the three sort of disciplines we're going to look at, and this is why I think automation engineer is a tricky job title. In the same way that DevOps engineer is a job title associated with the culture, automation engineer is pretty similar. So what I'm going to focus on is test automation. So probably the most common, probably when people think of automation engineers, they are thinking of QAs. So that's quality assurance engineers, who, yes, primarily will work with automated testing these days. I think we've seen manual testing has very much faded a little bit. We'll be looking at build automation engineers, so build and release engineers. So that's the automated DevOps process, which, you know, works hand in hand with the automated test process, continuous testing, alongside continuous integration. And then probably the least common, but I think something that we're seeing more and more, particularly in some big companies. I know Netflix are really, really big on this. I think, Darren, I think we were actually at an event where nationwide we're talking about working to ensure that their own staff had better tools and better systems to use. I'm not sure if you recall.
Yeah, no, exactly. From a automation perspective, and it kind of goes on to next week's conversation as well. They were looking at like chatbots and how they can automate things through those kind of means. So obviously, the more you can automate something, the less humans you're going to need to do the mundane tasks, is probably the best way to put it. So obviously, you want your human team to be doing tasks that are of real value add. And there's some tasks, especially when working in the banking sector, the computer systems isn't going to be fully privy to. So that's how they were using it. And I know that there's a lot of other companies at the moment that are doing great things with automation.
Yeah, absolutely. Yeah, and I think they were actually, Nationwide actually was sending their senior management and things like that on site to their call centers, to their contact centers and things like that, and literally, you know, watching how their staff were working. And I think at times they were a little bit horrified to see how many clicks it took to do certain things, and you know, they're building all this amazing software for their end users, but their internal users, you know, are dealing with quite clunky software, and you know, all credit to them for recognizing that and then working to try and improve it. So I think when we're looking at internal automation, it's definitely more of a responsibility than a job title, but it's increasingly a responsibility that is getting more and more common in the market, which is basically improving your internal systems. Like, you're only as good as your own staff in most industries. So the more that you can make their lives easier, simpler, and also cut out little manual tasks, will also mean cutting out, you know, silly little errors that maybe are just made, you know, by tired staff or things like that. And then, as Darren says, it allows those staff to work on other things. So yeah, these are the three areas we'll be looking at. Cool. So I've already talked through some of these, but I think these are the four big benefits that we'll see throughout all of this presentation. So automation massively impacts the quality. So I think when we're talking about test automation, that needs no introduction. The better test coverage you have, so the more of your program you're testing, but also the quicker you can test, the more repeatable those tests are, and the less often you have to write new tests. Obviously, it's going to massively increase the quality of the product that you're putting out, because you're going to catch a lot more bugs in production. Speed, again, if you're not having to write new tests again, if you're not having to you know, constantly rerun the same scripts and things like that, if you've managed to automate that process, then you're going to get things out quicker and a lot easier as well, you know, in terms of the capacity of your developers. Allows them to maybe be working on the next feature or working on the next project, rather than, you know, reiterating what they're currently doing. And then it's repeatable and scalable. So if you've managed to automate this process, you've automated it well, you've configured it well, then that can then apply to new features, and you can basically run your test scripts across more and more kind of infrastructure, which also means that it then becomes more scalable if it's set up correctly, because again, you're not having to repeat that each time. I think when we're looking at build and release engineers, we've already touched on this a lot during the DevOps presentations, but DevOps massively increases the quality, speed, ease, and scalability when you bring a DevOps culture into the business. And then again, when we're looking at internal tooling, well, obviously, if you can, as I said, cut out those silly little mistakes that people maybe make by automating some of that process, then you're going to increase the quality of the work. You're also going to increase the speed of the work, because you're taking some of those repetitive tasks out. Makes it easier for your staff. They should be happier and more engaged because they're able to work on more complex projects. And again, it's more repeatable and scalable. If you've automated a lot of those little day-to-day tasks, then you can work at scale. Maybe you don't need, you know, maybe you are okay with the team you have now because you've managed to save them, let's say, cumulatively 40 hours over the week. Great. Well, that 40 hours that you maybe would have spent on another person for the team can then be distributed amongst the staff you already have, and it's essentially like having you know, an additional member within the team. So I think they're the four main benefits, I would say, to automation in general, but we'll explore those a little bit in more depth as we go through.
Talk to us about test automation.
Cool. Lovely. So automated testing is the act of conducting specific tests via automation. So a set of regression tests or something like that. That's opposed to conducting them manually, whereas test automation refers to automating the process of tracking and managing different tests. So while they sound the same on the surface, pretty much every company is using automated testing. That is essentially running running test scripts, writing a test script, and then rather than a human manually going through and clicking on certain things, what the test script does is it mimics that human behavior. So rather than a human taking, I don't know, hours and hours to test a certain page, that automated script mimics the behavior and will test whatever you would have tested in a manual way. However, what it won't then do is kind of learn and retest and apply that to other areas and start to actually automate the whole process. You still have to kind of set that up initially. If we could skip to the next slide, please, Dave. Yeah, here we go. So as we say here, automated testing means using an automation tool to execute a test case suite. So on the contrary, manual testing is performed by a human sitting in front of a computer, carefully executing the test steps. Once the test suite is automated, no human intervention is required, but crucially, humans still write the initial test script to mimic the behavior of a manual tester. What test automation is talking about, which is what we're going to come on to, is the infrastructure of the machine being able to learn, okay, great, so this is how they wanted it tested first, and then actually automating that process of building the test. If you can do that so that your system is essentially automatically running its own tests, and then you have a good reporting system like Nagios or something like that, then you can just be constantly get that information fed back to you, rather than saying, okay, great, we need to run a test script to test for this type of bug on this particular feature. If you set a proper test automation, the system should already have done that for you. If we can skip to the next slide, please. Lovely. So this is where you want to get to through test automation. It's continuous testing. So you'll have seen these graphics on various different presentations that we've done, from the DevOps one to some of the software development ones and things like that. But continuous testing means that you're constantly testing. You're then able to, analyze the data. You're then able to design a new feature. You're then able to implement, and then you're constantly testing. So that whole testing process is kind of taken care of for you. So continuous testing is a relatively new approach to software testing, and it aims to ensure quality at all times. In a kind of traditional environment, the test gets completed at the end of a development cycle. But as more and more companies are kind of moving to that DevOps and continuous delivery model, you need to be testing throughout the entire process. So leaving testing like right till the end, where that isn't really an option anymore. You might get to the end and then realize that a lot of it doesn't work, or actually you spent all this time making sure that all these features integrate, but individually the features aren't performing as they should be. So in order to continuously be delivering and integrating new software, you need to be continuously testing it. So rather than, I think it's described as, rather than doing a kind of big bang at the end of the process, you're doing it in kind of small incremental pieces all the way through, so you get there and it's all done. So and while kind of ensuring the quality is utmost within this model, but it also massively counts towards the speed of development as well. So if your pipeline stalls or if it breaks down, it holds up everything else. Whereas if you've been obviously testing all of that and you're making sure that as it's going forward, it's all working and it's all correct, you're going to have less setbacks, and you're going to be able to get to the end of your project overall in a much quicker way. Cool. So the main roles, I think, within test automation are an automation tester, and again, you'll see multiple job titles out there. You might see QA engineer, you might see software test engineer, and various different job titles, but essentially an automation tester is the role. So they use automation frameworks and design and implement test cases dependent on the project. They're responsible for the kind of creating, enhancing, debugging and running test cases, as well as organizing, monitoring, defect management, process handling changes, various different things. So they're in charge of your overall kind of test strategy, and they would obviously be integral in setting up your continuous testing model. And Estet, in layman's terms, is the developer who, instead of working in the product development team, works as part of the test team. So in essence, Estets are responsible not only for writing code, but they require to write test code as well. So they can build you tools that will better test your internal software. They can work with your testers and your devs and your DevOps engineers to set up that continuous testing process so that you're actually automating the entire test process for your project. What that also means is they also kind of fall within that internal tooling automation discipline as well, because they are software developers, but their main goal is on making the internal process and the internal structure a lot more fluid and a lot faster, easier, higher quality. Cool. So we've got here a list of some of the best automation testing tools for 2020. So you see there Selenium is still on there, Catalan Studio, SOAP UI, some of the ones that are very popular. If we skip to the next stage, there's a little bit of information on each of those. Great. So we can see here, test software in general has been around for a long time. If we look at UFT there, since 1998. But I think Selenium is still by far the most popular one on the market. And I think we ran some of these comparisons with some of the DevOps tooling as well. And I think, again, you can see why the Selenium tool is very popular. It works with Java, C#, Perl, Python, JavaScript, Ruby, PHP. So basically, regardless what type of software house you are, chances are you're going to have at least one of these, at the very minimum JavaScript. So in terms of access to the talent, it's quite easy in that sense. Works on Windows, Mac OS, Linux, and Solaris. So whatever operating system you're running, chances are you're going to be able to work with Selenium on there as well. It does require advanced skills for tool integration. But again, that's where your Estets and your your automation engineers that can code come into things. And in terms of ease of use, it requires advanced skills to install and use. So not the easiest tool to use, but very accessible based on your platform or your kind of chosen scripting language. And then we see there's some information on the other four kind of popular ones. But you can have a look through that when we share the presentation at the end.
So now we're going to talk about build automation. Yeah,
great. So build automation, the process of automating the creation of software build and the associated processes, including compiling computer source code into binary code, packaging binary code, and running automated tests. So anyone who listened in on the various DevOps presentations we've done, or the cloud computing, or even the DevOps tooling one in particular, a lot of this will be familiar to you. But essentially, it's automating that process of if people remember back to source code repositories, one of the kind of key elements of the DevOps tool system, it's automating the process of once the developer has added their code to that repository, it then automates that build process. So it pulls the code into the required area to integrate with the existing software. It packages that binary code, and then it runs the automated tests. So heavily linked to that continuous testing methodology that we've just been talking about. This is the continuous delivery side of it, of which the testing is very much a part. Cool. So I'm not sure on how black and white this is. There are articles out there that kind of go through the difference between a DevOps engineer and a build and release engineer. I do think it is a bit of a semantic argument at times. I think there are a lot of companies out there that call their build and release engineers in the same way that they call their SREs, their site reliability engineers, and their cloud engineers, DevOps engineers. Like, it is still very much an umbrella term. So don't, I think we've touched on this every week so far, Darren, just about kind of not taking job titles at face value.
Yeah, I actually agree. I think the DevOps in particular is the one that is very difficult to do on. And then we'll kind of touch on AI next week. It's kind of the same in data science, where a data scientist are they the same as data analysts, but it's more of a Silicon Valley approach. And what is an AI engineer? So tech is probably the area more than any other vertical where you see a lot of semantic decision making. I think for me, DevOps is is a methodology, just being totally honest from all the reading I've done and all the conversations I have.
Yeah.
But just because you're calling someone a DevOps engineer doesn't necessarily mean you're wrong. I think it comes down to personal preference. It's easier for me when you get to more like platform engineers and cloud engineers, because then you can see what they're aiming at. But when it comes to SRE, build and release, and DevOps engineers, I think they're muchness for muchness, and you're probably better off looking at the skill set you're trying to capture rather than what is the job title.
Yeah, absolutely. Yeah, I mean, we see it every day that there are plenty of DevOps engineers out there that are very much involved in managing, running, setting up the whole build and release process. So yeah, I think it is something to be a little bit wary of. But I think if we are defining them, so some kind of definitions between the two, a DevOps engineer would create style guides for software and applications, maintain company goals for the product's performance, track bottlenecking issues with deployment of programs and updates, and understand tools such as Bamboo, Chef, and Puppet. Whereas a build and release engineer would be utilizing Linux or Unix throughout the build process, would be reviewing code for the software build architecture, would create plugins that will improve the automation process. So again, that internal tooling, and would be researching solutions to automation issues and integrating these into the system. So heavily automation focused, but as I said, I'm not convinced there's as much of a black and white definition between the two. I think build and release is one specific responsibility that a lot of DevOps engineers will have, and it's whether the company has divided them up into an SRE, which is focused purely on site reliability and reporting on the existing system, or build and release, who are purely focused on building and releasing, building the infrastructure to then automate the releases for any of your new features. Or as Darren said, platform and cloud engineers that are more focused on like the infrastructure side. Some companies have divided their DevOps engineers up into all these various different roles. Other ones still very much house them within that umbrella title. Cool. So the challenges and benefits for kind of build automation. So a lot of it in terms of the challenges come down to the computing power that you have available, which is why automation has absolutely blown up since cloud engineering and cloud computing became so viable and so popular. Again, if you want to go back to the cloud computing presentation, we talk about the added computing power that it gives you. Allows you to not just be working on the power of one machine, but have a hell of a lot of memory and a hell of a lot of CPU power, some computer unit power to back that up, because longer builds take more time to run. So if your system is struggling to run such a huge build automation process, then it can increase the developer's wait time and thereby reduce productivity. So essentially, you can kind of bite off more than you can chew at times. Large volumes of builds. So if you've got a large volume of builds running, then you will get limited access to build servers for that specific period. So again, it's biting off more than you can chew. Can your system and your resources handle the amount that you're trying to release? But I think with both of these, if you make sure they're well managed and you understand your system resources and things like that, absolutely things that you can get around. And then complex builds. So for an incredibly complex build or something that's completely new, you probably will still need some manual efforts to kind of edit some of those. Might be the test scripts, it might be your build automation process that you've got in place. It will still need kind of manual intervention here and there, because as much as it is automating the process, it is still learning from what has come before. And I think Darren will probably come on to it next week with AI engineers and how any meaning we extract from data is only as good as the data that it's given. So if you take machine learning, for example, the training data that you put in will very much dictate your output. If you put biased training data into something, then your outcome will be biased. And it's the same with test automation. When the system is looking at completing your automation coverage, it's going to learn from what's gone before. So if it's a completely new feature or a completely new way you're asking the system to interact, then you're going to have to step in manually to kind of get it to that level. But the benefits of automation build tools, they save you time and money in the long term. Once you've got them set up, you're then not having to repeat those same tasks, which then obviously becomes scalable as well. But primarily it's saving your DevOps engineers, your build and release engineers, your software engineers time, because it's allowing them to get things out faster. It keeps a history of builds and releases. So again, when we look at that repeatability and scalability, well, knowing how things work and having issues tracked are huge for how are we going to implement the next feature or the feature beyond that, because you're able to then pick out little issues with the system or pick out areas which could be improved. And I think that harks back very well to the configuration management element of DevOps. If you know how things are configured and you've managed that well and you've got that well documented, then you kind of know where you're able to go, because you've got that map, you've got that blueprint listed. Dependencies on key personnel will be eliminated through these tools. So again, you don't necessarily have to wait for someone else in the business to take a look and run their scripts or do what else they need to do, because you've managed to automate that process. So both yourself and that other person can then work on the next thing, accelerate the process, and it'll perform redundant tasks. So you'll take some tasks entirely out of your business. And that comes back to what I was saying a little bit earlier about then you can start to think about how you can use these people in a more creative or less kind of manual, repetitive way. Cool. So in terms of the DevOps tools, again, we've gone through these in a lot of depth in an earlier presentation, so I'm not going to go too much depth here. But if you do want to listen back, I think in series 1 there's a whole presentation on DevOps tooling where we go through everything from source code and repositories right the way through to your kind of monitoring tools and things like that. So end to end. So I'd recommend going back and listening to that if that's something that's of interest. But just kind of headline on each of them. So you've got Gradle there, which basically helps you push live. It's a really reliable build tool, helps you push things live a lot faster, and has really good configuration possibilities. So it'll log the way things are configured and it'll allow you to really easily change that configuration. Git, I think, needs no introduction. So both GitHub and Bitbucket have like amazing integrations. For example, you can integrate into Slack, so everyone in your team gets notified when there's a new commit and things like that. So it really improves the communication within the team and allows the developers to be adding their code to that central repository as and when. Jenkins, I think, you can iterate and deploy new code really quickly within Jenkins. Allows you to measure the success of each step of your pipeline. So I think it is the go-to continuous integration tool, to be honest, on the market at the moment. We've got Bamboo, which kind of seamlessly integrates with the Atlassian products such as Jira and Bitbucket, so your reporting software, as well as your source repository, and it gives you access to kind of built-in Git and Mercurial branching workflows and test environments. So it's a really good place to kind of get your team collaborating and working together on various different projects. So there are a few headlines really on some of the tools there. But as I said, if you want to go back, learn a lot more about Docker, Kubernetes, Puppet, Ansible, all of the other ones on there, and why they might be the best tool on the market and what it is that they do, then I'd really recommend going back and look at that DevOps tooling presentation.
You can find it on our website, hackajob.co, and if you go under the resources section, you can find all of the previous presentations, videos, everything there.
Great.
So internal tooling, Phil.
Yeah, lovely. So I think this is the one where I think the other two, it's easy to define them as a role. Automation or QA automation engineers exist. We all see them every day. We all recognize they are out there. Same with Estet, same with build and release engineers, even if there is a bit of a confusion about whether it's a responsibility or a job title, and that varies company to company. When we're looking at internal tools, like often it's a responsibility or a project. We are increasingly seeing it emerge as a discipline and as kind of something that is very specific within certain companies. So I think over the next few years, we will see this become if not an actual job title, certainly something that a lot more companies are looking at. And I think Vodafone we worked with, I think at a certain point, they had some internal improvements going on where they had people focused purely on internal projects. And I think we've already touched on Nationwide. I'm sure there are lots of other examples out there. I know Netflix do a lot of it. So internal tools can be any internally facing software developed by a company to support internal operations. So it could be bespoke technical tools, platforms and libraries built to increase the productivity of other teams, or CRUD interfaces that enable customer support to resolve support queries. So, on every level of your business, there will be these little tasks that take either too long or are too repetitive or whatever it is that you're trying to automate. It might be, giving your salespeople better access to information about, the types of calls they're having, even just something as simple as call length, calls made, things like that. So you might have that reporting software already integrated with your business, but if your business is quite niche, there might be certain elements that you want to report on that aren't typically built into your standard CRMs and things like that. So I think all businesses would be able to point to certain areas where if they had the resource, then it would make sense to kind of automate them. So some really interesting data. I will share the full kind of article in Slack a little bit later, so you can have a look through the full report. But really interesting report all around kind of internal tooling, how important it is. So they surveyed lots of developers. I actually can't remember who it is that ran the survey off the top of my head, but I will share that afterwards. But yeah, they surveyed a lot of developers. So the next, I think, 5 slides are all the findings from those. And it's quite interesting to see like how integral certain companies are seeing this. So how critical are internal tools to a company's success? So we can see here the vast majority went with very critical, whereas very critical and somewhat critical, whereas not critical at all, barely a couple of percentage points there. So I think from a developer's standpoint, it is something that they are very focused on and feel that it is something that is very much needed within every business. Cool. What are the biggest problems teams face when building internal tools? So not enough time and resources is by far the biggest one. And I think that comes down to the business's priorities. So they've obviously not been given enough time or resources to work on those tools. And I get it. You want to push your next feature live, you want to push your next product live, you want to get it out to consumers, because then at the end of the day, that's how you're going to make money in the long term. But if you can then disassociate yourself from that a second and think, okay, but if we devote some resource to internal tools for the next 3 to 6 months over a 2-year plan, how many features is that going to allow us to get out? Or how many more calls is that going to allow us to handle on a day-to-day basis? Or whatever it is that your challenges for your business, you have to think a little bit long-term when you're looking at internal tooling. But I think one thing that I've come across, certainly when speaking to companies, is that they feel like internal projects aren't the most exciting. Developers want to be working on projects that are going out to market and things like that. Now, according to this data, that doesn't seem to be the case. And I've actually got a bit more information on an article written by an internal tooling developer a little bit later, which may shed some light on kind of why that is. Cool. Percentage of teams' time spent on internal tools by company size. So again, we can see here, the bigger the company gets, they're spending more and more time on their internal tooling, which makes sense. The more developers you have, the more that you can afford to be having some developers spend time kind of working on your internal processes, making them smoother. Whereas if you've got a very small development team, you probably need them all working on your product. And also the benefits you're going to see will typically be amplified with a big business. If you're talking within a startup or something like that, optimizing the workflow of 3 people, yes, that may give you certain bonuses, but is that going to be enough to mitigate the money you would get from releasing a new product? Sorry. Whereas if you're talking about a business of 10,000 people, if those 3 people become 300 people, well, then suddenly the benefits start to add up a little bit more. Cool. And then percentage of companies with full-time positions dedicated to internal tooling. So we see here within kind of engineering, which I think makes sense. I think definitely within any factory-based or anyone who is manufacturing something that is going out to market, then automating your internal processes and using developers and software to do that is absolutely crucial. We then see for product roles that dips a little bit, for data that dips a little bit more, and then for design roles, that's not seemingly something that is too popular. And that might just be because that for design, there's loads of great tools on the market already, so you don't actually need to build a lot of your internal tools because you can go out to market and bring one in. And then finally, so percentage of companies with full-time positions dedicated to internal toolings by industry. So again, interesting to see that consultancies are there at the top, which again, I think makes sense if you think about their business model, the scale that they're working at. Obviously, we said that enterprise businesses tend to spend a bit more on it. And obviously, if you're working on multiple projects across multiple sites, then the better your internal systems are to track that and communicate and work, collaborate across different sites, the better you're going to be able to deliver into your clients. Cool. And then finally, what type of internal tools are companies building? So things like dashboards, so better reporting, giving your staff the data they need to do their job. Admin panels, so that could be, I know on HackJob we have talent advocates who work with certain candidates to make sure that they are prepared for their interviews and that they've got everything they need. So our admin panel would be something that would allow us to assign a different talent advocate to a particular user. Customer support tools, so that could be things like power dials in order to ensure that calls are coming through in a regulated manner. Data entry or collection tools. I think data entry is probably the most monotonous job out there. So anything that a company can do to improve the quality of life of their staff that are dealing with that, I think is always massively appreciated. Resource and infrastructure management, and then inventory management, going down to the least popular types of tools. Cool. And then finally, which teams at the companies use internal tools? So it is the frontline staff that are more often going to benefit from this. So your customer service and support teams, the ones that typically are doing the most repetitive tasks all day, every day. Then your kind of engineering and data teams. We just touched on why automation is so important to software engineers, to DevOps engineers, to QA engineers, but also to data engineers as well, which is kind of automating, and Darren, I'm sure we'll touch on this next week, but automating the process of collecting the right data points and then automating the process of making sense of those, so that data engineer and data scientist responsibilities. Cool. Why in particular would they want to build internal tools? So I think there are a couple of reasons, and I think this goes against the kind of commonly held assumption that developers want to push software live and be responsible for saying, hey, I was involved in this particular release for this feature that did this. Actually, what we found when Better Cloud, surveyed a lot of the developers they were working with, actually developers really enjoyed creating internal tools because, one, you're improving the quality of life of the people around you, so you're getting instant gratification. So when you can sit and run a focus group with members of 3 or 4 different teams within the business, you can collect their ideas, you can understand what their issues are, and then you can go away and do something that makes their life easier. Well, one, it's good for your, you could release a new feature, and I mean, the hope is that it does well. The hope that your new product on the market does well and brings in a load of money for the company, but there's no guarantee there. Whereas it's a little bit more guaranteed if you can save 100 people 10% of their time in a week, and then you can think about how can we utilize that time effectively, then it's almost a no-brainer. Like, you are going to see some positive results from that, and you also keep your internal staff happy. You create a better culture within the business because people feel like they're listened to, and the business is trying to evolve their role and improve it, and you get instant gratification. Rather than waiting for the product going to market, you literally see the kind of happy smiling faces all around you. So actually, a lot of developers are very keen to work on internal projects, particularly if they're advanced internal projects that involve kind of data streaming and some advanced automation. Then it can be a really good way to engage people and get them interested in working for your company. Cool. So what makes a great internal tool specialist? So good communicator, I think, goes without saying. Quite often, different teams will be facing similar issues. So if you can be communicating with members of different teams, running focus groups, running sessions, ensuring that you're aware of what the issues are, then suddenly, you know, an issue that's affecting 5 people in one team, you might discover is affecting, you know, 5 people in 10 teams. And then suddenly you've got a much bigger issue on your hands, as well as having the benefits, you know, massively outweighing the cost. If you can improve the speed and the quality of the work of 50 people, then, you know, within most size businesses, that sounds like a no-brainer. Empathy as well. I think it's easy to dismiss concerns of other teams. You might think, oh, it's not that hard, or oh, it's only 4 clicks. You know, why does it have to be 1? But if you're someone that's doing that every single day, and you're repeating that every single day, and every day it's taking you 30 seconds, 40 seconds, a minute, whatever it is, longer to do that one task that you do 100 times a day, then it is really big to you. It might seem so minuscule on the surface, but actually to you, it's a big pain point with your role, and it would save you a lot of time having that fixed. The ability to spot patterns as well. So you're not just looking at the actual tech side, you're looking at workflows and patterns and things like that, because some of these might be able to be fixed with a process change rather than actually bringing in a new tool. Obviously, you want to make sure that the tool, you know, that it is necessary to build the tool. If you can solve something in process in a week rather than spend 3 months building a new tool, then you would go with process first. So you have to be able to communicate, to empathize, and spot those patterns and those pain points within different workflows. And then you can start to build a case and collect that data to kind of go at the business and say, look, this is what we need to do. And then the usual stuff. You know, they are still software developers at the end of the day. So, you know, as we've touched on all the way through all of these presentations, good coding standards, things like best practices like TDD or knowledge of BDD and things like that absolutely still apply to internal tool specialists. Cool. And then there are kind of 2 main methodologies behind this. So there's the planned approach, or there's the organic approach. So the planned approach is essentially you have already kind of collected the data, you know what the problem is, and you're essentially going to just push that into your standard software development life cycle or whatever it is. So you'll go to your project managers, you'll start working on prototypes with them and things like that, and then you'll move it through the process as you would any other feature that you were building. Or organic. So this might be where you maybe don't have complete data yet, or you're not entirely sure whether the business will be able to go for it, and that is when you will organically, as the internal tool specialist, build a model, build a simulation essentially to show where the pain point is currently, and what the improvements you could make would benefit for the business, i.e. we will save X amount of time, or we will deploy features X amount quicker. Cool. And then the kind of response, I say roles, but as I said, it is more of a responsibility, but you might see internal tools developers out there in the market, internal automation engineers that are more focused on automating processes rather than building tools. And then Estets fundamentally are internal tools specialists. They are building your software that allows you to automate the tests.
So now we're going to look at deconstructing experience and salary.
Yeah, lovely. So I've pulled the diversity stats from LinkedIn Talent Insights, and then the salary information from Nuvo. It had the most complete salaries for these, but so we can see here QA salary for London, I believe this is, average is about 46,000, which I think makes sense. Does tend to be slightly less well paid than software development, and obviously we do see that transition from automation engineer into software development. Typically, if they're going the other way, then you'll become an Estet. But what is encouraging, I think, within testing is the diversity is a lot better. I think that's probably something I would have assumed anyway, just obviously from knowing the market over a number of years. But it's nice to see that LinkedIn kind of validates and backs up that data. So I think if any companies out there are looking to try and increase their diversity, then one way to do that might be looking at kind of cross training from automation. Build and release engineers, so build automation engineers, typically earning around 65,000 per year for the UK, which I think again sits about right. DevOps engineers tend to be paid a little bit better than software engineers, and I think that 65k mark looks about average for someone who is incredibly competent when it comes to building and releasing software. So you're not just a junior DevOps engineer that's maybe done a bit of cloud infrastructure or things like that. Like these guys are very competent with automating your build and release process, and as we can see, they're paid well for it. Whereas the gender diversity does come back in line with the industry average, which is about 9-1. And then finally, we've got some information here on Estet. Again, I think fairly accurate in terms of what we see on the market in terms of salary there. Estets tend to have come from a software development background, or they are automation engineers that have then been taught to program. So obviously adds a significant amount to their salary. And because they are a little bit rarer, I think that pushes them a little bit higher typically than what you would see from a software developer. And what's really encouraging, based on LinkedIn's talent insights, is actually there are 29% females working within the London market within Estet. So that is really encouraging. And again, I think that possibly is down to some kind of positive action by companies in training up female software developers into an Estet role, which is certainly an option. Cool. And then just finally to kind of wrap things up, in terms of the availability across the UK, again, using LinkedIn. So in terms of QA automation engineers, they're just over 100,000, which I think, yes, again, kind of goes along with what we see. They are quite abundant in the market. Obviously, hiring a highly experienced automation engineer that has worked with a certain amount of tech, specific tech, at a certain salary, you are narrowing that bracket down. But there are plenty out there on the market. Build and release engineers. This won't tell the full story because obviously there are other job titles that they fall under, but about 48,000 in the UK. So not exactly buoyant, I would say, but at the same time they are out there and they are able to be found with Estet. And again, this does come down to the job title. I'm sure there are other candidates out there on LinkedIn that aren't actually labeled as a software developer in test, but based on the same type of search as the other two, that only returned 3,100 candidates. So very much still in unicorn territory. And if you are looking at Estet, I think Capital One did some really interesting work a few years ago where they were basically bringing in software engineers that they were going to basically upskill within test and create Estet. So again, that's probably an option if you are looking to go down that route.
Okay, and yeah, I guess we have finished pretty much right on time. Did we have any questions today, Darren, or do you want to save them for later? He can't find his unmute button.
We lost Darren.
Realised I'm on mute. No, the questions came through quite early, so I answered them. So I think
okay,
quite
perfect. Well, thank you so much to everyone for joining us. We'll send out an email later, basically with the slides and the video as well. And yeah, so next week is our final session before our summer hiatus, and Darren will be taking us through AI engineering. So yeah, really exciting. So big thank you to Phil today for taking us through this really great session. And yeah, like we say, we'll link it through to everyone afterwards. So yeah, thank you so much, guys.
Great. Thanks, guys. Bye.
Bye.